So Daniel, thank you so much for taking the time. I think, the first thing I would really want to know a little bit is tell us a bit about yourself. Like, what led you to this point in your journey?
Sure. So actually, funnily enough, given how computer science focused the project is, I didn't start out as a computer scientist. So I did mechanical engineering at Imperial College, very much focused on engines and things like this. Realized I really don't care about that too much. Wanted to try to go into computer science and all the kind of sexier stuff like robotics and everything. It's not so easy in the UK to change degrees, so I was kind of locked into engineering. And then decided to just try to push with what I could on self-supervised projects and kind of YouTube learning and stuff to try to go into computer science. Luckily, was then able to leapfrog into computer science PhD, which then obviously enabled me to dive much more deeper into my software engineering skills and everything. And actually, then this was the birthplace of Ivy, really, or at least it's where I got the motivation. Basically, we had a research lab where everybody was doing computer vision and robotics, but everybody was using different frameworks. It started off with everyone using TensorFlow, but then we had PyTorch users, we had someone using Chainer, some new people using JAX, and we ended up with a very fragmented set of tools where we were all doing very similar work, and we ended up re-implementing functions in all kinds of different places. So I was then incentivized to create a framework that enabled people to write libraries and such functions once and then share them with everybody. And I did that because I suppose I got the impression that the fragmentation in the lab was very much mirrored in the whole of ML. So I kind of went from having no code experience and doing like one big long Python file in a slightly embarrassing amateurish project to then trying to, becoming a bit obsessed with software engineering design and kind of diving deep into all of this. So that's a bit of context and background.
Got it. That's super interesting. And then was your PhD based on the project that you ended up creating, which is Ivy?
So actually not so much. The research was all very much kind of 3D vision and robotics related. So actually it certainly isn't a lab that has anything to do with like software engineering design and unification of frameworks or anything like this. So really it was something unrelated, interestingly enough. It was the kind of place that gave me the inspiration, but Ivy is something that really has no direct bearing to the research of the lab or the PhD.
So if I may kind of summarize, I mean, even though this was not exactly your core focus of your PhD or even your originally, like you had a really like a personal frustration that you had to address. What your colleagues were working on.
Exactly. And I was basically wanting to work on multiple projects as well. One project was all in PyTorch, one was all in TensorFlow. I wanted to create my own libraries and tools that I could use for years to come in my, as it was going to be then, researching career, which is now not what I'm exploring. And I'm very happy to have explored a different route. But I kind of wanted to have some future-proof safeguarding against everything that's built. That means I can integrate it into new projects and stuff. So yeah, this was a frustration that I had myself very much in the lab. Yeah.
And tell us a little bit about the early days of the project. Like, how did you get started? How did you even convince people to use it, or even maybe work on it? And also curious, like, what made you decide to open source the project in the first place?
Sure. So I got started on the project as any project starts, just starting simple. I think the initial version of the project, I mean, it's a bit technical, but it was kind of just a load of if-else statements inside each of the functions. It's like, if it's PyTorch, do this, if it's TensorFlow, do this, and then we have this more sophisticated backend handler, and there's more files, and it just kind of branches out from a super simple seed, as is the case in many cases, obviously. You just keep adding and adding and adding. So that's, I mean, kind of how it started, really. It was, 10 functions on the first week, probably. And so that's that. As for the open source decision, it wasn't really a decision. I guess it was a no-brainer, really. Everything in ML with regards to developer-facing APIs and tools where they can really customize things, which is what Ivy is. Ivy isn't just kind of a SaaS service. It's like a tool, and it's a framework, and it's not a language. It's a framework that people need to use and customize and build upon. So it kind of necessarily needs to be open source in some way. But also, I think early on, it was clear that there's lots of functions that need adding. There's lots of relatively low-hanging implementational fruit, which lends itself very well to like small contributions, small and meaningful self-contained contributions. And it's exactly the kind of project where open source contributions can hugely benefit the project. So these are some of the reasons.
So the draw of having contributors to kind of make their contributions almost independently was a huge driver behind the decision to make it open source.
Yes, exactly. Yeah, and that, I mean, so that's actually interesting to point into another point, because going to some of the design details a bit, but the backend kind of really needs to be open source, I think, just for it to be usable as a framework. But something that doesn't necessarily need to be open source is the front end API. So when we do these translations, we have the graph compiler to compile a graph. We then have these framework specific front end APIs to kind of transpile through the Ivy functional intermediate representation. And these front end specific APIs don't need to be open source, because they're not really there to be used as part of the framework. They're there to serve the role of the translations. But still, we did decide to make that open source because it's better for the community to have full access for everything, but also because it is the exact kind of thing where a community support and push makes a lot of sense. People find a bug, it doesn't quite work. If anybody can quickly make a PR and fix it, this is a big benefit for the project, for us, and for the community on the whole. So yeah, this is very much in our thinking. Yeah,
makes total sense. Now, I want to kind of cover kind of one of the main questions here, which is, what problem are you addressing with this project? Why would someone use it? And how do you think their lives get better by using Ivy?
Yeah. So I think the easiest story here, the most intuitive use case, I think, is somebody that's perhaps in an R&D team and is wanting to just pick and choose the latest state-of-the-art models to try out in their pipeline. And they're frustrated by, I mean, let's say you're a PyTorch user and DeepMind released an awesome paper, and what you typically need to do is either wait for somebody in your lab or company or team to re-implement this so you can then try it out, or perhaps you wait until it appears on the open source somewhere. But the devil is very much in the detail with ML, so maybe the initializer is a bit wrong, maybe things don't quite work, it doesn't quite get the results of the paper. So having the confidence to, within a few seconds, press a button and basically get the exact model kind of out the other end within hours of it going online is a big benefit for rapidly trying things out and getting them to getting your kind of prototype working. So that's the most obvious use case where Ivy can really flourish. But I think there's different stakeholders that interact differently to this. One of which is library creators are interested in maximizing their audience. So if I've created a big popular PyTorch library and with no extra effort from myself, I can suddenly open this up to TensorFlow and JAX without needing to do anything, then this is good for me as a library creator. And the last thing that's slightly more long-term is it's obviously kind of this grandiose vision every early founder has. But I think if we continue to see more fragmentation in frameworks, which I think is possible, Julia is an up-and-coming language. The creator of PyTorch is spending a lot of effort building the Dex language, which is this array processing language. If we see lots of kind of interesting things popping up, then we're going to see more fragmentation, and some kind of glue that enables all of these things to talk to each other will become increasingly important. Likewise, if we see more fragmentation at the hardware level, for example, there's GraphCore, there's FPGAs, there's IPUs with GraphCore, obviously, there's TPUs, there's AMD and NVIDIA GPUs, and Intel are branching into this area as well. So yeah, and then maybe kind of bio-inspired hardware down the line. I think if we keep seeing people trying to kind of take a unique slice of the space, all of these will have an interest to suddenly make their technology work with all the other stuff that's out there, so they can suddenly be relevant and everybody can use it. So I think if Ivy can kind of become this center point for people to engage with, to kind of suddenly plug into all of ML, then Ivy could be in a very good position where lots of people want to use it for lots of different reasons, I would say.
Got it. That's a really fantastic vision and makes a lot of sense. Maybe tell us a little bit about the progress you have had so far, and I'm thinking more about kind of the community of users you have. Like maybe give us a little bit of sense of what are the metrics you measure, and then what has been the progress along those metrics?
Sure. So metrics specific to, well, so there's metrics in terms of our own development progress, and this is very much thorough kind of to-do lists of functions to add and the unit test to get passing. And we have a CI, a continuous integration dashboard showing all of the test failures for each combination of framework and submodule and so on. So we're kind of constantly using our CI as a metric, but for the community as well.
I was thinking, sorry to interrupt, I was thinking metrics in terms of, how do you measure the progress of the project, like the user and community and, and those kind of things.
Got it. So that's a great question. And it's something that, to be honest, at the moment, we're only starting with. So we're quite early in kind of doing thorough tracking here. The obvious one, which is admittedly a vanity metric by some regards, is the GitHub stars. This is an indicator of who likes the story. Right. And this is one that we are happy with the growth, but of course doesn't tell the full picture. Contributors is good. And we're obviously, I mean, these things are easy to track. GitHub tracks it for us, obviously. But this is something that we are happy to see going up. It's now 300. It was, it was kind of, 5 at the start of the year. So that's gone up very quickly. But as things go on, the metrics that we'll be tracking become more complicated. Right now, it's quite light, and we are just kind of seeing that people like the story, and that's all we can really meaningfully track, because we are like heavy usage. People are resonating, the story is resonating with people, but people aren't like putting Ivy deep in their dependency graphs. Whereas when we have the first working version of the transpiler, when we collaborate with many people in the open source space, we will of course start to track how many people have this in the open source project, how many downloads on PyPy do we have, how many clones do we have, how many people of these are enterprise users, how many of them are students, and kind of start to profile who and how and why people are using things in, I guess, the way that probably most open source projects will. But the kind of concluding point is that we're quite early and we're not doing any sophisticated tracking on that front at this point in time, basically.
Let me double click on one of the things which I think is actually a pretty healthy metric for you. So if I look at the number of contributors you have, like over 300 for an early stage project like Ivy, that's actually really commendable. So I'm curious, like, was there any particular thing you could point to looking back that made you made it possible for a pretty large group of contributors to come in and contribute?
So I think some of the main things, one thing is that when we have interns apply, part of the process for them to engage with the project and actually make a PR. So this is one thing that's driven some of the contributors. But on top of that, of course, it needs to be very easy for them to engage. So and this is becoming a smaller and smaller percentage of the people contributing. As part of that whole process, we have made very thorough tutorial series. In fact, most of my effort in the last 5 months has been I spent hardly any time coding. It's all been spent on writing documentation that explains Ivy's design, explains how to contribute, explains how all these subtasks are separated into separate to-do lists on the issues, making YouTube videos. I'm doing a load of screen recordings all the time, every time I do fix and test myself. So I've kind of spent all of my time trying to build the infrastructure so that anybody can pick it up and doesn't have any questions to ask with regards to how they can make Ivy better. So basically I would say just taking a step back, I think there's two things there. I think one thing, it's not so easy to do that for all projects. I think Ivy also just has an easier job because we have hundreds of functions that need adding. They all follow the exact same roadmap of do A, then B, then C. And they can all just be done by different people. So a lot of projects probably can't quite so easily get meaningful engagement from so many people so quickly. But even with that formula, which exists in Ivy's design, of course, it still needs to be very well explained. So I think just putting a lot of emphasis on that. Being very friendly as well. I think we're always saying, hey, ask as many questions as you want, no silly questions. We're very deliberately welcoming of novices. People do ask questions that a sophisticated developer would never ask, and they make mistakes that someone that really knows how to use GitHub fully wouldn't make, but we're just very welcoming of that. So I think there's also people aren't so scared to engage as well, I suppose, is one thing.
I think one of the things you just touched on, which is really key, is how much time, energy, and effort you're spending on making it easy to contribute, like all the documentation, the videos, the tutorials you were doing.
Yeah.
And like if I were to kind of, glean one learning for, new open source, projects is
Yeah.
that, right? Which is like, how do you make it
Yeah.
easy for, someone who has never
Yeah.
touched board to
Yeah.
contribute, right?
Yeah.
And I think the second part you were saying is also identify the pieces of your project that are easy to contribute, right? I mean, in your case,
Yeah.
the functions, hundreds of functions, and which kind of
Sure.
follow the same roadmap. Okay.
Yeah. Yeah.
That's
Yeah.
fantastic. And then Daniel, like we all know that open source projects really fail or succeed because of the community.
Yeah.
You definitely seem to have a community that is thriving, buzzing. I'm curious, like looking back over the last 6 months or so,
Mhm.
what do you think you have some of the things you have done right to
Mhm.
continue to build a community? And then also I'm curious, what are some of the things that you felt like you could have done better, or learnings or
Yeah.
mistakes along the way? Again, I'm thinking like, what can you share
Yeah.
with someone who is
Sure.
starting fresh with an open source project?
Sure. Okay, so I think things we've done right is kind of echoing some of the things, obviously, from the previous question, that I think making it very clear, being very friendly. You want people in your community, and also just because it's much nicer, obviously, to treat people with patience and respect. So I think that, and making it super clear and easy to contribute, is really important, and we've done that right, I think. I also think one thing that has helped, in fairness, having 300 pull requests accepted and merged requires a lot of people reviewing pull requests. So we've kind of had something of a funneling effect, whereby in February it was just myself. We then have ramped up hiring of interns and other people onto the team, and they are then quite quickly responsible for reviewing PRs. So we can kind of have this thing scale quite quickly and elegantly, whereby we can be accepting 15 PRs a day because we've got a team of 15 or so at the moment. So so this is one thing that's necessary to just scale things quite quickly, which like we've done. So I think these are things we've done right and are working well. Things we've done wrong, I think one thing is we initially had some tasks that weren't independent, and actually it's a bit nuanced, but one of the early tasks people engaged with was modifying Ivy such that it adhered to the Array API standard. And this actually had a lot of tasks that heavily depended on each other, just because of how the Array API standard test suite is implemented. They effectively use every other function during every test. So when you test one function, it actually depends on 20 of them, because the unit test itself is implemented in those functions. So this was then a nightmare, because people's tests weren't passing, and it depended on 10 other people who were also doing theirs. And this just became very difficult. We ended up just needing to merge a lot of, or kind of progress. Basically people's PRs were all like deadlocked because of each other. So this is one thing. Try to keep independent tasks that don't depend on other things if you want people to be able to engage quickly and meaningfully. And the second one is that I guess just another mistake we made is that we have sometimes dropped the ball a bit on responding to PRs quickly enough. And now we've got a PR dashboard that we check regularly, and we have constant alerts if anybody's been left with a PR that's not been responded to for a few days. But we did occasionally have people that slipped under the radar for 2 weeks or so. This is also a bit of a problem because, as I said, as part of the intern application process, people are engaging with the repository. So sometimes their application was actually held up, and this was obviously frustrating. So, and it was okay, and we got there and apologized, but now we're clamping down on that more. So I would also say, if things scale up too quickly and you don't have the infrastructure to track it all, then that's a risk as well, because you can end up, very fairly annoying people who are trying to contribute and are being held up by your own reviews and stuff.
So the responsiveness and building all the kind of the infrastructure, the metrics to really be on top of peers and quickly act on them, keeps the community going.
Exactly.
Have you done anything externally facing to promote the project, particularly with an eye towards users?
No, not really. I mean, so sorry, did you say particularly with PyTorch users? Sorry, what did you say at the end?
No, what I was saying is like, I mean, there's the contributor part of it and everything, but have you done anything externally to showcase the project to users? Like, have you like anything you have done that you can share?
Not yet, funnily enough. Given how much goodwill and people liking it we have, it's surprising in a way, because we don't have that much user-facing material. It's something that we're working on doing and changing, because over time the whole repository should become less well, not less developer focused, but there's sections on developers and there's sections on users. And right now there's only really a section on developers. But we are giving a talk at ODSC West in November. And this is where we're aiming to have it's like a 90-minute workshop where we're going to fully demonstrate the transpiler and kind of, I guess, the first kind of version with all these new features we're talking about. We'll have version 1.2 released by then. And then from that point onwards, once we have this foundation, then we'll start building tutorials and notebooks, and our whole internal team will very quickly move on to changing that. But no, basically the answer is not too much of this material yet.
All right, well, that's again, really commendable given the success so far, and very little investment, it seems.
Yeah.
Like. Just shifting gears a little bit, are there like other projects, whether open source or proprietary tools that you feel like, you kind of keep track of that are solving a similar problem?
Yeah, absolutely. So, I mean, just two things I should mention. I mean, Tensorly has a framework agnostic backend and did an awesome job with that. EagerPy also solved something very similar, but didn't quite go as far as us with the stateful API and everything. But they haven't kind of got huge mass adoption. Neither has Ivy yet, in fairness. But I think the most similar is ONNX is probably the most similar, and I would say these are complementary initiatives. ONNX is kind of a static representation for neural networks that is very useful in enabling trained networks to be run on any hardware. And it's something that Ivy can, we're not going to reinvent the wheel there. But what Ivy uniquely enables is the ability to have this kind of flexibility and portability, but also at training time, even with legacy code. So ONNX, people need to buy in. Then TensorFlow then bind to ONNX and PyTorch bind to ONNX. Whereas we just say no one needs to do anything. We can just like wrap legacy code, new code. We can kind of do all of the work by wrapping the function API, and we can make this work at training time as well. So there's nothing out there as far as I can see that's doing this in the way that Ivy is. But there's definitely complementary relevant projects that I think complement Ivy's goals.
So we're down to the home stretch, of this. I really am enjoying this, but a couple of last few questions. So one is, if you were to build a business on top of Ivy as the open source, like in your mind, what are the one or two things that you feel like need to happen for you to really build a business? Like any quick thoughts on that?
Yeah, so I think one thing is that, well, so I think already in order to be able to build a business, we need, well, Ivy needs to really work. I think if we only work half the time, that's not good enough. And for enterprises to depend on us, Ivy needs to really work. I think we depend on innovation in AI remaining high, so people still want to bring in state-of-the-art models and try the latest and greatest and try the latest libraries, so that the R&D story continues to make sense. I also think Ivy thrives in a world where fragmentation remains an issue. I think this is, for better or worse, this is what we're seeing, as I've said, with all these different hardware vendors, GraphCore and IPUs, Google TPUs, GPUs, FPGAs, all the frameworks. There's obviously the big monolithic three, but Pandas, like Learn NumPy, all of these things would benefit from crosstalk. So I think in a world, I think that things that would lessen the chances of Ivy's commercial success would be less fragmentation and less need to prototype on new state-of-the-art ideas in AI, but I don't think there's any sign on those things going down. And I guess we're banking on companies and hardware vendors and SaaS distributed training vendors wanting to plug themselves in quickly to the whole ML ecosystem and benefit from that kind of wider network rather than their subset, and we can kind of profit from this with licensing, etc. So yeah, hopefully that kind of touched on that with a few different angles.
Got it. That's super interesting and helpful. Maybe two last questions, and they're kind of interrelated. Sure. So, feel free to take them at once. But sure. Like, is there anything that, looking back now, you feel that, or you wish that you had known when you started, with the Ivy project? It could be like specific to the project, or just the whole open source strategy. And I'd ask the second question. Like I said, it's related, which is like, what would be your advice to someone who is kind of starting on this path, just about to start on this path of building an open source?
Sure. So they're good questions. One thing, which I don't think it's a disastrous thing, but actually, interestingly, when we started Ivy, there was no notion of the compiler and the transpiler. So we learned quite quickly that I think I had like some optimistic naivety a little bit early on, which was I thought we're going to make Ivy. To some extent, I thought we make Ivy, we show that it's framework agnostic, that it works with all these things, and people then want to start writing all their code in Ivy and all their models in Ivy on day one, because now you can create a library and it's all in Ivy. You can create a model, it's all in Ivy, and that has been showing good traction, but it then only came later that's like, well, we've got all these huge repositories like PyTorch Geometric, or I mean Hugging Face, and a load of repositories that are very sophisticated, very deeply integrated tool chains, and they depend on PyTorch and so on. And these aren't obviously going to suddenly reinvent everything and re-implement it all in Ivy. So basically, then it became clear that if we want to have a big impact on everything that's already out there and be useful for all of that, then we should be doing something like transpiling between frameworks. So I guess I wish it would have been good if I had had the insight when I first started toying around with it 2 years ago, because then we'd be further along the roadmap. But having said that, I don't think that's kind of a disastrous kind of realization to have had a little bit later along the journey. And then the second one, just general advice. So that's very specific to Ivy, so that's maybe not so useful for somebody else. For somebody in general starting out, I mean, for open source in particular, I would say, first of all, try to make sure you're solving a problem that resonates with people, and it needs to be, I guess, broad enough, and make sure nothing out there exists that's already doing it, because I think it's quite easy to kind of create 10 versions of the same thing. So I guess like it's good if you feel as though it is unique and it's solving something that's not been solved. Obviously, make sure you really love the problem, because you'll probably be diving into the weeds for many years, I suppose. So you've got to really kind of have the passion and the determination to get it all the way through. And yeah, I don't know. I guess also, and yeah, I mean, certainly with open source companies and stuff, I guess, yeah, I think with any company or anything, you need to be in love with the problem more so than the idea of a startup or something or anything like this. And then also finally, obviously, with it being open source, I guess the more small working parts that can be independently worked on, the better. But of course, that depends on the problem. So you're not always in full control of that structure. But this has definitely played to our favor, I think, with the community building.
Got it. That's super helpful, actually. And going back to one of the points you were making earlier, I think it is super useful. It's not just Ivy specific, but it is super useful to think about how do you plug into an existing ecosystem and make it really easy for people to use it, right? Use the project, because a lot of people will pick up an open source project more as a trial and hobby kind of thing. So to the extent that you can really make it easy to use for a single player, without dropping everything they have invested in, I think it makes a lot of difference.
Yeah, no, that's true. And definitely, I think if you can make something that sits on top or sits with what's already there, then and this is obviously PyTorch Lightning does that. It doesn't try and say, hey, drop it all. It's like, hey, we can just build this on top, and many other very successful projects. Obviously, Hugging Face has a model repository you can just plug into what you've got. So yeah, I think that's a really important piece of the puzzle as well. Yeah.
Fantastic. Daniel, this was fun. Thank you so much for doing this.
Thank you.
I really appreciate it.